So just the brief recapitulation of the things that we have already studied, that diversion headworks, the main component of diversion headwork is a wire or a barrage. Someone's microphone is turned on, just mute it. So the main component of your diversion, হ্যাঁ কি হ্যাঁ বল কিচ্ছু শুনতে পাচ্ছি না, কথা কেটে শুনতে পাচ্ছি না, তোর কথা কেটে কেটে যাচ্ছে, শুনতে পাচ্ছি না। হ্যালো, পরে বলিস, মেসেজে লিখে দে, এখানে কমেন্টে লিখে দে, বা পরে আমাকে ফোন বা টেক্সট করিস, কিছু করিস, আমি শুনতে পাচ্ছি না। হ্যাঁ, so let us start. The main component of your diversion headwork is wire or a barrage. Okay, so basically what is the difference between wire and barrage? Your in case of barrage, the crest is at a low level and above it gates are being installed that can be opened and closed as per our wish. The crest here is low for barrage, okay, and for your wire, what happens, the crest is high enough, okay, and above it shutters are placed. The shutter height is quite small with respect to your crest height. So here the water level is up to this. So generally the hello so generally the water level for your wire is up to is not at the top of your crest, is underneath your crest, but here in barrage the water level is higher than your crest level, okay. So basically this is the difference. Basically this is the difference between your wire and a barrage. And there are three types of wire. You can see that there are three types of wire. One is vertical drop wires, another is rock fill wires, and another is concrete wires, okay. So what happens in vertical drop wires? So here what we do, this is known as, this part is known as the wire wall. This acts like a wall, na, it diverts the water, so this is known as wire wall. So this wire wall can be constructed in three different ways. That is, both the upstream and downstream side can be vertical, like this, the water level is up to this. So both the upstream and the downstream side can be vertical. Another one can be like, the upstream side is vertical and the downstream side is sloping. Why it is being made? Because previously this was the vertical thing was only being made previously, but after that this has become obsolete, because there is hydraulic jump during the rainy season. There is hydraulic jump like this happening. So due to this gradient, the shock is being absorbed by this wall. If it was vertical, then the water would have directly fallen. In this case, what happens, the water falls like this, the hydraulic grade. So this part, this floor gets cracked due to the sudden impact of water. So in order to avoid that, what they have done, they have just made this one inclined, so that the water jumps and falls on this, and this is going to be absorbing a lot of impact. water is going to come around, like this, and fall on this wall, and is going to shock, absorb the shock, and like this part of the floor is not going to be affected due to this. So this was being adopted, and further correction, it was seen that the water is coming like this, is hitting this surface like this perpendicularly, and the
Sir,
effect.
screen is not visible, sir.
Oh no, the screen is visible, is being written as you are presenting. Nobody is able to see it.
अभी visible है sir. अभी दिख रहा है.
दिख रहा है ना सबको?
Yes sir.
सुनाई तो दिया ना मैं क्या बोला?
Yes sir. Yes sir. Audio is clear, but screen I am.
Is it
अभी
visible?
screen visible है. Visible है sir.
पेंट में मैं it is opened in paint. Is it visible, the paint? Can you see the paint?
No sir.
Yes, sir.
Oh, I am reaching.
Just everybody check. I have opened the paint and I am drawing it on it. So for you people to understand. The paint
Yes,
is
sir.
visible, na?
Yes sir. Yes sir. Visible.
So what is being done here previously, the wall face was made vertical both in upstream as well as downstream, okay, but it was being observed that in the rainy season there is hydraulic jump and the water falls in this way. The water climbs and falls here on this floor, so this particular area gets affected and it gets cracked. So in order to avoid that, there was a slope that was provided on the downstream side, okay, and the upstream was kept vertical. So this wall could the hydraulic jump, you can see that there is not much of a jump. The water coming from this will just get on this face, and there is not much of jump. Hydraulic jump is not much here in this case. So this was being adopted, and the floor here does not get affected. So this was being adopted, and after that it was being further observed that the river is coming in this direction, is hitting this wall perpendicularly, and you know that perpendicular impact is the highest impact. The torque produced is maximum. F cross F, R cross F, you know that the torque R cross F. So for sine 90 it becomes maximum, right? I think everybody know it. R cross F, torque. Hello.
Yes sir.
Torque equal to R cross F.
Yes sir.
So for 90 degree, that R cross F means what? R into F into sine 90 with the direction according to thumb rule. So for 90 degree the impact is going to be maximum, right? So it was being observed. It was being observed that the wall, that the this wall on the upstream side is the impact here is much more. So there are cracks happening on this face also, it was being observed. So in order to counter that also, a slope has been provided like this, okay, and what happens, the slope here is more than this, so it is more or less vertical, but a gradual slope is also provided here. So, and this is 1:4. Generally it's being adopted 1:4, and this slope is being adopted 1:20. The slope here is more slope means more, it is vertical, okay. So this part is being made like this, and the slope here is being made quite less, okay. So this kind of structure, and this wall is made of concrete, sorry, it is made of masonry, means bricks and masonry, stones are being used for your construction purpose. This wall, this is in every case, these are wire walls. Okay, this one, everything are wire walls, and these are masonry structures. So this particular type of wire is known as, all these three types are known as vertical drop wires. Okay, and next comes your rock fill wires. So next thing, what was being adopted is that it was seen that the construction of masonry structures, it requires, the cost is high enough. So in order to counter that, what was being done, a general wire is being constructed like this. Okay, and in order to increase the slope, rock fill materials are used to increase the slope. We just put rocks here. Okay, we just put rocks here to increase the slope, and further here also a gradient is being made, and the rocks are being filled up here also in this part, so that further there is, the hydraulic jump is even less. For that purpose, what we do, we fill up the both the upstream and downstream sides with rocks or rock fill materials. Okay, and as this slope is quite low, means the rock fill materials, more rock fill materials are used here. So what we do, we have to insert core walls in the intermediate positions. We have to insert core walls. What it does, it does hold your uh, rock fill materials together, means they, due to the rock water action, turbulence of water, it won't get carried away, the rocks won't get carried away. If we put the core walls, it will hold the rocks together, so the slope will remain like this. Have everybody understood the difference between those two? Basically both are the same things, but in case of your vertical drop wires, what is done, the complete structure is masonry. Even the slopes, everything are done by masonry structure. But in rock fill structures, we build the wire wall through masonry only, but after that the slope is being made through rock fill materials. From the side, nearby sides, we take up rocks and we fill up the upstream and downstream with rocks in order to increase, and in order to decrease the slope, we just fill it up by your rock fill materials. Okay, have everybody understood?
Yes, sir.
Yes.
Yes, sir.
So the next point that comes is your concrete wire. What is being done? These rocks somewhere in your side, means remember this one is important for your exam. The Okla wire that is situated in Delhi, across the Yamuna river, that is an example of rock fill wire. It comes in the exam. There is one example that you need to write it down. So Okla wire is one example of your rock fill wire. Okay, so next comes your concrete wire. What happens in concrete wire? Why concrete wire is first being adopted? Let us first concentrate on that. So suppose if the rock fill materials are not available to us, means in a site maybe where we are constructing the diversion headwork, there may not be abundant rock fill materials that are available in the site. For that purpose, you won't be taking it from another state, because the cost is going to be high, the transportation cost. So for that purpose, and also it requires quite amount of labor, because the laborers need to work hard, and also plenty of labors are required for it. So in order to counter that, what is being adopted is concrete wire. What happens in concrete wire, you can see that there are no masonry structure, only the floor, that is being made here. Look in wire, this is the wire. You make one impervious floor here. Okay, in order to avoid the percolation of water from this point to this point, there is a tendency of water to percolate from this point to this point. So in order to avoid this, floor has been set up. Okay, so the floor is being set up, and that floor has to be impervious so that water cannot flow from this juncture to this juncture. Okay, and in case of your concrete work, that impervious that particular impervious floor is being constructed in this type only, in this pattern, means the somewhere the it's being made plain, the height keeps on increasing, then it becomes plain, then it again keeps on decreasing the slope. Just here, the where, as you can see, the slope keeps on, it becomes constant, then it keeps on increasing, then it becomes constant, then it decreases. Similarly, that sloping thing is done by the floor only. The floor is constructed at irregular heights. In order to get it, in order to get that particular configuration, what we do, we construct the floor accordingly. No masonry structure or no rock fill materials are used here. Only the floor is constructed in this way. Okay, am I clear?
Yes, sir.
Okay, so next comes the modes of failure. So just hold on. So what are the modes of failure? Modes of failure can be by two ways, that is subsurface flow and surface flow. What do you mean by subsurface flow? Suppose this is a particular word. Okay, so what do you mean by surface flow? Surface flow means from the top of the surface there is a flow of water from the top of the surface during high tides or rainy season. There is there is flow from the top of your crest. This is known as the surface flow. And subsurface means underneath your structure there is look, there is a impervious layer being adopted, but you cannot construct the total river across. You cannot put a impervious layer across your whole river. So for that, it has to be restricted up to a certain length, but beyond it, where there is the starting and ending, beyond it there is no impervious layer. So water percolates from this point to this point. Okay, so there is a flow like this within the soil. There is a flow of water within the soil, and this is known as subsurface flow. This happens, why this happens? Because there is a difference of height. The in the upstream side the water level is like this, and in the downstream side the water level is like this. So due to this difference in your head, there is a percolation of water. There is seepage, rather this is known as seepage, that is flow of water below the ground surface due to differential head. This is known as seepage. So there is seepage occurring, and this is known as your subsurface flow. Okay, so there are two types of subsurface flow. There are two types of failure that occurs due to your subsurface flow. One is uplift failure. Hello.
Sir, yes, sir.
Yes, sir. So there are two types of failure that occurs due to your subsurface flow. One is your uplift failure. Another is your piping failure. Okay. So what is uplift failure? look, this is the way your water particles will look to seep through. Okay, this is the property that happens in case of your you have studied seepage in soil mechanics, I think you have already studied that. So due to the difference in head, what happens, the head of water applies this difference of head, means this head is more than this head, so the difference of head, this in head of water applies force on particles. There are particles here na, there are soil particles here. This difference of head will apply force on particles. So what will happen, this force they will be applied here, and this the inter particle forces between these soil particles will tend to get reduced, because there is a force like this acting. Okay, so due to this the interparticle force.
ज़्यादा बात जा आ गया
Is getting hello, is getting disconnected.
Yes.
Yes, sir.
The screen just, another screen is visible, right?
Yes, sir.
So due to this difference of head, there is a force being applied on the particles here. Okay, and due to this force, the particles, the contact force between these particles, soil particles, will tend to reduce. Okay, the contact force reduces between the soil particles, and as a result what happens, there is separation between the soil particles, like this the soil particles get separated due to this application of force due to the difference in head. Okay, so the soil particles tends to fall apart. So due to this, there is pore water pressure that is developed, there is pore water pressure that is developed due to the disintegration of the soil particles. There is pore water pressure that is being developed, and as you know, the pore water pressure that acts upwards. Okay, so that is known as the uplift pressure, or the uplift pressure, and that causes your uplift failure. Okay, have you understood?
Yes, sir.
Huh. So what happens? What we generally do? We insert the floor. We do construct one floor, one impervious floor. We do construct it always for the your in order to resist your percolation. What we do, seepage. What we do? We insert one. We construct a impervious floor. So what we do, we put some weight on this floor. So what will be done, that floor weight, this is the floor, right? This is the floor, there is one weight, suppose that is W, and there is uplift pressure of P, suppose. So if the W balances is good enough to balance that force P, then there won't be any uplift. So we do construct that floor, and also we put some weight on that floor in order to make that floor weigh enough so that it can resist that uplift pressure or uplift force. Okay, so another thing that can be done is that this is your wire. What we can do, another thing is that we can increase the seepage path length. How can we increase the seepage path length? This is the seepage, right? This is the seepage. How can we increase the seepage path length? We can increase it by inserting piles here. If we insert piles here, what will happen? The water here has to go through this track. It cannot, piles are impervious layer, right? Here water cannot go through the piles. So in order for water to go to this point, they have to go through this. They have to cover a lot of distance, and then only they can get it here. Okay, so what we do, we provide piles, so that increases your length of your seepage, that increases the length of your seepage path length, rather the seepage path length increases, and due to this a lot of head is lost, a lot of head is lost in seeping. Okay, and as a result the pore water pressure that will develop will be less. Have you understood? So what we'll be doing, we'll be inserting a pile here, and what pile does, the seepage path length, it will increase the seepage path length. Okay, so as the path length increases, the lot of head will be lost. The water head that will be here, as it has to travel a lot underneath, the water level will come down due to the fact that it has to cover a lot of distance from within the ground. It has to cover a lot of distance, so the head will be lost here, so the difference of head will be less. So as a result, your pore water pressure that will develop will be less, and that will result in your less uplift pressure. Okay, have you understood? So this is the method that we adopt in order to prevent uplift. Have everybody understood?
Yes, sir.
Yes, yes. So next comes your piping failure. Though both of those two, that is piping failure as well as your uplift failure, both of these come under both of these come under your subsurface flow. That subsurface, because is concentrated uh, within the soil, means under the structure it happens. Okay, so next comes your piping failure. What happens in piping failure? This is your wear wall. Okay, so suppose this is your impervious floor that is being constructed from this there will be a seepage, and it will be like this. Okay, so what happens here, there are soil particles, right? There are soil particles, and this is the nature of the flow of the water. So the soil particles here will act tangentially. The force is acting tangentially like this to the curve, right? So here it has one component, like this tangential force has two components, right? That is, one is like this, one is like this, right? It has two components. So what happens, due to this force, the your soil particles tends to get washed away. It tends to get washed away. So there is a hollow here happening. There is one hollow means just like a pipe. What is a pipe? It's a hollow structure. So similarly, there is a hollow being developed here. So due to the percolation of water, and there is a force acting on these particles along the path of percolation of water. There is the soil particles that are present here. There is a force acting due to the percolation of water, and the soil particles looks to disintegrate, and as a result they look to get washed away, and there is a hollow happening here. And what happens due to this hollow, the previous particle, it starts to get washed away also. The previous particles that is just adjacent to your this solid particle, that's this soil particle, it also gets washed away. Similarly the previous one also gets washed away, and like this there is complete washing away along this line of the soil particles. All these soil particles along this line get washed away. So what happens, there is a hollow pipe like thing that happens here. There is a hollow pipeline thing that happens, and water can easily guess through this point and percolates to this point. Okay, so due to the fact that there is a pipe like thing happening, this is known as piping. The failure occurs due to this is known as failure by piping. Okay, so how the as because this is a hollow thing happening, so the structure will tend to subside here. There is a hollow like thing happening here, so the stability of the structure won't be there, so the structure will look to subside in this hollow surface. So there is so in terms the structure will look to collapse. So this failure is known as failure by piping. So how it is encountered? What we do, we also insert piles at this end also, in your downstream side also. Same theory that the your that cut off piles, if you insert, your seepage path length will increase. So it has to come like this. If it has to come again like this and go like this, so what it helps in not forming this pipe thing. This pipe won't be forming. So we insert your cut-off piles at the downstream side, as well as for the upstream we have inserted piles in order to counter that uplift, failure by uplift. You have inserted that your piles, as well as in the downstream also we will insert piles. Okay, and another thing that we can do, we can insert inverted filter at this point. What it does, inverted filter is a mechanism that allows seeping water to escape at the exit. It will just throw out this water, that the water that is being percolated from this point to this point. It will just it acts as suction pressure. It will just suck it out and it will throw that water out. Okay, that inverted filter. So these two things can be adapted. You can see that in case of your concrete wire, you have seen that in the layout it has been given that the sheet pile is being inserted here in the upstream as well as downstream, as well as in your masonry, means vertical drop wires. Look, both in the upstream and downstream, both there are sheet piles. So basically this is the use of sheet pile. Okay, you have to provide it both in the upstream as well as in the downstream. Do anybody have any doubt?
No.
Hello?
No, sir. No doubt.
Okay.
No doubt.
So next comes your surface flow failure. as I've already told, the surface flow means from the top of the crest. Okay, so there are two types of failure that occurs uh, uh, due to this. That is, one is, you can see that one is by suction pressure and another is by score. Okay, so first thing, look, the water here will tend to jump. There is a hydraulic jump, right? So there is a force that is acting upwards in this way. Due to this construction of wire, there is a force acting upwards. So there is a hydraulic jump here. So there is already a force acting upwards, that is due to that uplift pressure I have already told, that force is acting upwards, and also due to this hydraulic jump there is a force acting upwards. So this uplift force as well as your this force, this hydraulic jump force, that vertical force is known as suction force, and this adds on with your uplift pressure and it adds to your instability of the structure. Okay, and another is by score. So what do you mean by score? Look, the water here is due to this hydraulic gradient is falling like this. So where it's falling, it becomes a cavity on the floor. It becomes a cavity. So there is erosion of soil that's taking place due to this impact of water, constant impact of water. There is erosion of soil that is being taken place. So how do you counter that? There is a pit being developed and we apply stones. Okay, stones, quite loosely packed stones are being used here, that is known as launching aprons. What we do, we place it here in this pit, we place it so that there is no washing away of soil. Okay, the impact is being absorbed by the loosely packed stones, that is known as launching aprons. It is being absorbed by that. So if it's being absorbed, then what happens, there is no erosion of soil that is taking place due to the your impact of water. And yeah, so that is the only measure that we can take. And for this your suction pressure, what we do, the as I've already told, in uplift we insert weight on it, on the impervious floor. Similarly, that's weight only, the floor weight, that will be only used in order to counter that upward force. This force acts downwards, and this uplift force plus your suction force both acts downward upwards. So this flow weight will counter this force. Then only if it counters your upward force, then only the structure is stable. Okay, so there are few design aspects. These things I have already mentioned. You just go through the what are the design aspects, that inverted filter is being inserted, and all this your piles are being inserted in the downstream as well as your upstream side. Your impervious floor is being designed also. Surface flow, what are the measures being taken, I have already mentioned. And one more thing, there is another energy, a device is required at the downstream side to dissipate energy. Okay, a device is also being means here a device is being built up so that it can absorb the energy. So these are the methods, few methods that are being adopted in order to counter your failure, but by failure by so due to the surface flow as well as surface flow. So just go through it. If you can understand, then tell me. I've already mentioned this while telling about the remedies. Okay. So any doubt you have?
No, sir.
Okay. Everybody clear?
Yes.
So okay, I will be sending the Google form, that quiz. Just give one response only, means one response means not one question. I am telling that do fill up once only. not multiple response like you did in your steel class. Many I saw did 4 5 responses. Don't do that. Okay. So tomorrow within 12 o'clock, 12 noon, you submit it. I'll be sending it through mail. Okay.
Okay, sir. Okay, sir.
So thank